Hi guys, we are starting our new unit over here on polynomials, and it's called Unit 4, but it has a little bit of 5 in it. These are the things we'll be doing in it. We will work with polynomials where we'll add, subtract, and multiply. After we add, subtract, and multiply, we will take those polynomial expressions where you add, subtract, and multiply, turn them into then after we add, subtract, and multiply, we're going to have more expressions where we'll factor them. Then when those expressions are equal to something, we're going to solve those equations using your factoring. And then we'll have some applications, which are some word problems. So here are the sections you're going to be learning. Today you will be learning section 4.1 and 4.2, which is going to be a video, and then some follow-up homework. During the week, before I see you again, I'm going to ask you to take some more notes on 4.3. So when you come back to class, I think on Friday, I will see you next, you will have 4.1 done, 4.2 done. I believe we're going to go into either 4.3 or 5.1 next. Not sure, but you will be awaiting another video. But your first video today will be on 4.1 and 4.2, with homework accompanying 4.1 and 4.2 the video. So just letting you know, these sections of 4.2, 5.1, and 5.2 are all the laws of exponents, and there are 7 laws of exponents. You learned all of them in Algebra 1, so it's just going to be a review of 7 laws, and in addition to that, some like harder, meatier Algebra 2 type problems. So when you use those laws of exponents, you will then simplify. So after you use your law of exponents, we're going to do some multiplying of polynomials, which you've done. You probably remember the word FOIL. So when you FOILed, you're going to have some harder polynomials also, in addition to just FOILing, some Algebra 2 like one. Then you'll have a quiz. I can't predict when your quiz will be. It most likely will not be in the first marking period, but it could be. I'm not sure. It's either going to be the very, very end of the first marking period, or it will be the end of the first marking period or the beginning of the second marking period. So your quiz would be on 4.1, 4.2, 4.3, 5.1, and 5.2. Then after that quiz, we will be factoring polynomials, factoring quadratic polynomials, which sound easier. So I do a little bit of 4.6 before I go to 4.5, and then I go back to some harder 4.6 again. Once we learn to factor our polynomials, which you guys know how to do, you showed on your prerequisite test, you know how to factor. You're going to factor some harder ones. Then we're going to solve these polynomial equations by, of course, factoring. Then we have a quiz on 4.5, 4.6, and 4.7. For now, this first quiz is you can use any calculator you want. I will let you know about the calc on this one. Then we'll have some word problems and some work with end behavior. End behavior is not in the book, so we can call that 4-point golly if you want. And then we'll be solving some polynomial inequalities. This is remember when we had this 4x minus 1, and I said, what is the domain of this? And the domain was, well, of course you remember, you just had a quiz on it. 4x minus 1 is greater than or equal to 0, and then you solve this and you say x is greater than or equal to 1/4. So you would call that 1/4 to infinity. Those aren't the polynomials we're solving because that's linear. If you had a question like this, y equals the square root of 4x squared minus 1, and now you have to say 4x squared minus 1 is greater than or equal to 0, you need to do this one. This one was done through algebra. Very easy through algebra. Miss Golly is going to teach you this through graphing. It's kind of a fun section, actually. It's the very last section if you want to take a peek at it in this book over here prior to of course, the SAT type questions. It's right there, or maybe over. Well, this is the end behavior stuff. It's kind of a neat section. And then the word problem section, and then the solving of the polynomial equations are right here on page 77. It looks like a short unit, but there's talk about a very, very, very crucial, critical unit. And then there's a test on all of the above. So this is a chapter that's so important, especially the factoring section, because if you don't really know how to factor, there'll be a lot of things in Algebra 2 and in pre-calc you won't know how to do. So let's start turning to page 5 in your book, where we're going to add and subtract polynomials. I know I wrote down the words already because I'm going to be talking while you guys write down the words that you're going to learn. This could all be found on page 167 in your book if, you know, it's not filled in exactly with words that you want. I will never test you, I don't want to say never, but I'm not going to test you on words like what is a constant, define a monomial. You know, I might say, what is the coefficient of the term? What is the degree of the polynomial? But I won't say define polynomial. So anyway, what is a constant? A constant is any number that's kind of being added. So if you have something that's 5x squared plus 3x plus 2, the constant is this right over here. So a lot of times I'm referring to the constant. So again, it's not like I'm going to test you on the word constant. I'm going to say, add the two constants together, and you have to know what a constant is when you do that. So when I think of a monomial, I'm going to go down to a polynomial first, and I'm going to show you an example of a polynomial. So a polynomial can be this right here, which I just wrote, right? I wrote up there. And there's 3 terms here. There's 3 terms in this polynomial. And in this 3-term polynomial, we end up calling it a trinomial. So what is a monomial? A monomial is just the one term of the variables with the coefficient, or even no coefficient, or no variable. But if there's no coefficient, the coefficient's 1. So let me tell you what a numerical coefficient is. If you have this monomial, like negative 8x, like 2x squared, like how about if you have a non-monomial and it's a trinomial, 5x squared plus 3x plus 2, okay? This right here is the coefficient. It's the number in front of the variable. This is the coefficient. This is the coefficient. So you got a coefficient of negative 8, of 2, of 5, of 3. And over here, the reason the 2 is not called a coefficient is because what is it called? That's right, a constant. Let me throw another one in front of there, like 8x minus 4y plus m, okay? So as you can see, the coefficient here is 8, but the coefficient on that one is a negative 4, because you take a look at what is being added, and terms are added. Even though you see a subtraction sign, terms are technically added. So 8x is being added to negative 4y is being added to 1m. And of course that coefficient is invisible. It's just 1. So when I think of a degree, I'm going to go down to a degree of a polynomial, because a degree, this is what they put in the book. What's a degree of a monomial? Variable of a monomial. What's the degree of a monomial? This is what, let me go to the polynomial first. So if I see something like this, 2xy squared plus 4xy plus x to the 4th plus 7. This is an entire polynomial. You know, monomial is a polynomial. You have to, when they talk about what is the degree of the monomial, they're just picking that one thing out. And they're saying, okay, here's your monomial. What's its degree? Well, you add up the exponents of the x, which is the 1, and you add it with the 2, and that degree is 3. So it's a third degree polynomial, which we call cubic, by the way. I'm not right there yet. And what do they mean by the degree of one of the variables? That means that one of these variables have a degree of 2. But the entire monomial itself is a third degree. So if this one's a third degree, and this one right here would be a 2 degree, and this one right here would be a 4th degree, and this one would be a 0 degree, the entire degree itself is the highest of them. So the highest of it is 4. And by the way, the lead the leading coefficient is not who you think it is. It's not 2. The reason is you have to rewrite this in order to put the polynomial correctly. You have to write it with the highest degree first, the next degree second, the next highest degree third, of course the last one last. So the degree of this is this one right here. You put it first, and the lead coefficient is the lead guy right there, number 1. Even though it looks like he's the lead, because they write it that way. So any other kind of important things you should know? Let me at least tell you what the degree is in words. It's the greatest of the degrees of the monomial. Monomial just means one term. Monomial terms. So when you simplify it, I was showing you over here, one of the things that needs, in order for it to always be simplified, here are some conditions. It is arranged in descending order of degree. And I did that for this one right here, see? This is 3rd degree, 2nd degree, 4th degree, so I put the 4th degree first, the 3rd degree second, so on and so forth. The other condition is all like terms need to be combined. And the third is all parentheses gone. So you need to like distribute or whatever. So what do they mean by combining all like terms? So let me go to the like terms section. So if I listed a bunch of monomials, 3x squared y, and 8x squared y squared, and 7xy squared, and 6xy, and 10x squared y. There's only 2 like terms there, but they look, a lot of them look pretty similar. They got x's and y's, and some of them have degree 2, and some of them have degree, like this has a degree 2, this one has a degree 3, he has a degree 3 too, so does that make them like terms? The answer is no. Here's how I think of who a like term is. Take away the coefficient and see if they look exactly alike. So if I took this coefficient away, it'd be x squared y squared, xy squared, xy, x squared y. So this one and this one are the only like terms. But now that I have their coefficients in front of them, I would then add them together at some point, or subtract them, or do whatever they want you to do in the operation they ask you to do. So when you add these like terms, you got to remember this. One like term plus another like term is just another like term. People make that mistake too much. Look at the difference between these two questions. If someone asked you to add x plus x versus someone asking you to multiply x by x, and they're both in this unit, but this one's in this section. Today's section is adding and subtracting. So 1x plus another 1x is just another one. It's just another x, but what's the coefficient in front of it? 2x. But when you multiply x by x, you add the exponents and you get x squared. Memorize that. That'll take you far. So if I ask you to add these two like terms, you keep the like term of x squared y. You just add the coefficients. I could ask you to subtract them too. Okay, so that was a lot of vocab. And to me, vocab's not fun in math, but it's vocab you need to know so that we can speak the correct math language. Again, does Ms. Golly ask you, hey, like define coefficient? No, I might ask you true or false, but you need to know the language so we can speak to each other. Okay, so when I give the degree of this polynomial and identify the leading coefficient, I first need to simplify first. So if you don't simplify, you could be giving the wrong answer. So let's see if there are any like terms. Let's see. There's this x right over here and this 4x over here. See, there's negative 3x squared and 1x squared. And then over here, there is 8 and -2. So first I'm going to simplify them, then I'm going to put it in descending order, and then I'm going to put it in descending order, not descending order of coefficients, descending order of degree, so looking at their exponents. And then I'm going to give the leading coefficient. And then I'm going to give the degree. So adding these together, 3x squared and x squared gives me 4x squared. Then I'm going to add the x and the 4x, and I'm going to get 5x. Then I'm going to add the 8 and the -2, and I'm going to get 6. So that's in descending order of the exponents. My lead coefficient is, how did that, oh, nope, that's actually wrong because that's a negative. I already made a mistake. That is a -2x squared plus 5x plus 6. My lead coefficient is -2. My degree is a second degree, which we will be starting to call quadratic. Remember, linear was to the first power and quadratics to the second power. See if there's any like terms here. You do that. So you simplify that and then give me the degree. You can turn off your camera. And then you can give me the leading degree, leading coefficient. So turn off your camera, add them together. Put them in descending order of the exponent and then go ahead and answer that question. Okay. So you would have added these together and they would have actually canceled. You would have added these together and gotten -3x y to the 4th, and you would have added these together and gotten, what would you have gotten for those? 2x. Would they have added these two? So these two add together and you get -3x y to the 4th. Sorry, I'm struggling with this. And then I added these together and you would have gotten, I would have needed more space here. 2, those are not to be added together, sorry. These are not like terms. So I have plus 2x cubed y and then -4x squared y. That is of a 5th degree, a 4th degree, and a 3rd degree. So the degree of the polynomial is a 5th degree. We actually call that quintic. I'm not there yet with you guys in that though. And your lead coefficient is -3. Okay, now for the adding and the subtracting. So we'll turn this page so you know there's not much notes on this. And the only reason I put method 1 is method 2 is to give you guys choices. You guys can figure out your own way that you want to do it, whether it's going across or going down and lining things up. So I'm going to just rewrite this so that I could not mess it up for method 2. I want another clean one for method 2. You are not going to be asked to do 2 methods. You're going to be asked to do your own method. So get different colored pens and say, oh, this one and this one are like terms. And do 1 underline. And then say, maybe I'll do 3 underlines for this like term and this like term. Maybe I'll put a dot for this like term and this like term. Or I could do like a little bridge, whatever you want to do. So when you add all those like terms together, this guy had nobody, but he is the highest of the degrees. So he's x cubed, then -3x squared, -1x, and then these guys canceled. That's method 1 just means go across, find everybody, underline them, make sure you have the like terms together. Method 2 is just asking you to do this. Write out your 2x squared, write out your -3x, write out your 5. That's the first one. Because see, we're just adding this one with this one, which is all we did right here. We added them. So now when I go to write that one, I go, oh, I'm going to write the x cubed under his like term, which is nobody. The 5x squared under his like term. The 2x under his like term. And the 5 under their like term. So I'm just going to add it together. So it's sometimes easier for you to organize. It's an algebra 1 concept. So I don't want to like run it into the ground. I want you to add in the way that you feel comfortable. Okay, so on the next one, again, remember this, and this will take you far. If you have x squared times x cubed, and you have x squared plus x cubed, this right here in another section will be x to the 5th power, because you're adding so we'll say x to the 2 plus 3, you add the exponent and get x to the 5th. This right here is already simplified because they're not like terms and you can't add them together. So you see how these were like terms and we added them together, but remember one like term plus another like term is just another like term. So if I'm going to subtract them, you could subtract them going down, but if you're going to subtract them going across, you need to remember that you need to distribute that as a negative. So you may need to do a little rewrite. X cubed minus 5x squared plus 2x minus 5. So I'm going to rewrite this. 2x squared minus 3x plus 5 minus x cubed plus 5x squared minus 2x plus 5. Think of all your like terms. This guy has no like term. This guy, notice when I underline them, like I'm going 1, then 2. It helps me with the order I want to write them in. So that'll be the third one. And maybe you'll do this, I don't know, because 4 are a lot to look at. So as a final answer, I get negative x cubed plus 7x squared minus 5x plus 10. Try to remember, one like term plus another like term just gives you another like term. Notice how I'm putting it in degree, descending, 3, 2, 1, and that's of degree 0. So if you guys want to try that one on your own, you can. This one's a little harder, but try it on your own if you want to turn off the camera. If you don't, just wait for me. And then this is going to be a solving one. So first on this, I'm going to distribute the x, and then I'm going to distribute the 4, then I'm going to distribute the negative 3y. So this gets written as 2xy minus 3x plus 4x plus 8y plus negative 3xy plus 3y. There's really no descending order here. When you have two variables, it's really hard to make sure there's a good descending order. It's not something the teacher will necessarily look for. She just wants you to make sure you're adding your like terms together. I believe these two add together. And is that it, maybe? So you get negative 1xy for those two. These guys give you negative 1x, or it's positive 1x. And then this guy and this guy add together and give you plus 11y. Not really any great order of descending. I suppose I did descending. That's a second degree. Maybe I did do descending. All right, now this one's a little different. This one is solving to just find out what the missing a is, like a puzzle almost. So here's what you do to do this. What you do is you think about, you're going to match the coefficients of this to the coefficients of this. So first you have to simplify this, and then you match it with this one. So what you're doing is you're writing out, well, let's start simplifying already. So we get ax cubed minus 3x squared plus 2bx minus 2. What we're going to now do is subtract 2x cubed plus cx squared plus 5x plus 4d. I'm going to worry about this guy at another time and say, what are the coefficients of this? This coefficient, and I'm going to say of x cubed, even though he's missing, you'll see why in a second, plus what is the coefficient of x squared, plus what is the coefficient of x, and I'm running out of room, and then this is a plus a negative 6. Why is this important? Because this coefficient is going to match some coefficient over here in a second. I'm going to run and see if I can get a highlighter also. So I'm going to put these underneath each other so that you can see me add this and this together. So I'm going to put ax cubed minus 3x squared plus 2bx minus 2. I'm going to now take this negative 2x cubed. It's plus a negative, so it's plus a negative. I'm going to make these all plus a negative 2x cubed. Then I'm going to put the cx squared under here, underneath this, the 5x here, and the 4d here, because I'm going to call all of those like terms. Now, you're not going to see an official looking coefficient that says 5x cubed or 6x cubed. When you add these together, you're going to add them, and it's going to be an awkward x cubed. But what would you call that? You would just, if that said 5x cubed and 6x cubed, you'd call it 11x cubed. But you can't. You have to add the a and the negative 2 together, and they're not like terms, so we're simply going to have to call them a take away 2 x cubed. It's awkward. I'm running right now to just go get a highlighter so that I can highlight a couple other things going on here. I hope I have other ones. I'm right here just looking for a highlighter for you guys. Oh, I got it. Sorry. I got some timeout. The highlighter idea is going to help, so that's why I'm here doing this. Okay, so that's an a minus 2. We'll call it x cubed because we couldn't call it an official coefficient. The next one we're going to add together is going to be a coefficient for x squared. So that coefficient is going to be, how about if I add them in yellow and I put that coefficient right here, and I call that coefficient negative 3 plus c, or c minus 3. This next one, I almost could have added it together, but I can't quite add it together because it's a 2b and a 5, and they're not like terms, so they can't add together. So the awkward coefficient for this one is 2b plus 5. And this one's just going to be a constant x to the 0 power, so it's negative 2 plus 4d. And I was able to find another highlighter real quick, and it's this right here. So now that whole thing is equal to this whole thing. So notice, maybe I'll make this like a little bit bigger over here, and I'll say something x cubed plus something x squared is what I'm just bringing down here, see that? Plus something x minus something, okay? Let's find their coefficients. So there was a reason that I wrote this coefficient, this term, because it's really a 0 right here. It's a 0x cubed, isn't it? And it's going to match the pink one. So it's a minus 2 is going to match the 0 coefficient. So the next one in yellow is its coefficient is a 1 right here. And that would be awkward if I wrote it in the yellow. You wouldn't be able to see it. So I'm going to write that this negative 3 plus c coefficient in front of the x squared is equal to 1. And then the next one is my purple one, and it's going to equal this coefficient of 1. So therefore I'm going to say 2b plus 5 is equal to 1. And then my next one is a blue, and I'm going to have negative 2 plus 4d is equal to this minus 6 that is falling off my paper. So this one again was just finding the missing values that would make this equation true. So the missing value is a is equal to 2. This missing value, adding a 3 to both sides, is c is equal to 4. And that's just, doesn't mean it's the order in front of the x cubed because the c came first. 2b plus 5, you minus 4 from 5 from both sides. 2b equals negative 4. b equals negative 2. And then this one, when you solve it, you add 2 to both sides. 4d equals negative 4. d equals negative 1. So you solved for them. They're solved for the missing values of a, b, and c that make the equation true. Now, one of your homeworks, and I'll put it up on Google Classroom to see how you should upload it, is to do 1 through 27 odd. You must copy all the original problems from the book and then show your work and make sure you check in the back of the book before we get to class and review. Where will you do that? I don't mind where you do your homework. A lot of people like to do it on lined paper. As long as I get it uploaded and as long as you guys can find it while we're correcting. But this is a nice notebook to keep everything in. I personally think so. Keep it all in together. Now we're going to learn section 4.2. So turn the page for some laws of exponents. So we're only going to learn 3 laws of exponents today. So in section 4.2, there are 7 laws of exponents. I actually bunched them together for you once we learned them all. I think I put them in a nice little spot for review. So if you guys think you know your laws of exponents already and you'd like to review all seven of them, I think I have them reviewed prior to the quiz, or I put them somewhere because it's your quiz outline. I'm pretty sure I did. I'll show you the page I'm on. Here it is. The page I'm on is 37. And these are your 1, 2, 3, 4, 5, 6, 7, 8. They say 8 laws of exponents. I think this is just not a law. It's just a duh, x to the first power is x. So these are your 7 laws of exponents used with variables x and m. And I might have put another one, or maybe I didn't. By the way, the thing I showed you that I said you must remember, which I review all the time with kids, is if you add 2 like terms, x plus x, you get 2x. But if you multiply, whether they're like terms or not, you keep, so this one is x plus x, you keep a like term. One like term plus another like term is another like term. You don't need like terms to multiply. You just keep the same base and add the exponents. That's what I'm teaching you today, by the way. Are these like terms 2x and 3x? Yes, so you can make it 5x. These are like terms, but you didn't need them to be. It becomes 6x squared. See this one? 4x cubed and 5x squared, page 37, by the way. That's simplified. They're not like terms. But you can multiply them together. You don't need things to be like terms to multiply them together. So let's learn 3 laws of exponents before we learn 7 laws of exponents. 4 more after that. So today's objective is to use laws of exponents to multiply a polynomial by a monomial. And by the way, a monomial is a type of polynomial. Remember, there's, binomials, trinomials, monomials. A polynomial just could be more than one term. So here are my 3 laws you're learning today. But remember, there are 7. I have to premise it with, all right, just say 3 of the 7. That we're going to let A and B be real numbers, and M and N are referring to positive integers. Because if they're not, then it's a little different. It's not that different. It's just something you have to take care of later. So I'm using A and M. So if I have a same base to the mth power and another same base to the nth power, I keep the base and I add the exponents. That's all. Simple as that. And I'll give you an example in a second. Now, if I'm multiplying 2 numbers together to the mth power, it becomes, you can distribute the exponent. What people get confused with is they think, and this is, remember, my pet peeve, if you have a plus b to the mth, you cannot do a to the mth plus b to the mth. That's wrong. That's that pet peeve that I have. You have to multiply a plus b times a plus b out. So that is not a rule of exponents. It's someone making up whatever they want to as a rule, but it's not my rule. So the next one was a to the nth becomes a to the m times n. These are all rules that you guys have used in the past. So if sometimes, like, you have to think of PEMDAS too. Like, I'd like to think about this in terms of PEMDAS for a second. Let me bring this up here for you for a second and say, what would you do in a situation like this? If you had 5 times 2 to the 3rd power, would you use this rule that said 5 cubed times 2 cubed? And then would you do 5 cubed is 125 times 8, and that would be 1,000? I would say no, I'm not using the exponent rule. I want to do PEMDAS. PEMDAS says I can multiply 5 times 2, get 10. And 10 is so easy to cube, you get 1,000. So why would you use this rule when you could use PEMDAS? The answer is PEMDAS can only be used when you have only numbers. If you had something that said 5a cubed, you can't do PEMDAS. You can't multiply first because these guys are not multiplying. So you have to use your rule, 5 cubed, a cubed. Remember, exponential rules can trump PEMDAS. And I like PEMDAS better if I have just numbers, but you have to use the rules. You have to know the rules because all you guys are getting is a lot of variables. So let's take a look at these rules again. I'm just going to say an example of this rule would be this. X to the second times x to the third is x to the fifth because you added 2 plus 3. But this is x times y to the third. This is just an example. We'll call this one 5. 5 is better. And an example is 5 cubed y cubed, which would be 125 y cubed. And this one would be if I had x to the second, this is an example, to the third, it would be x to the sixth versus x to the fifth. So let's take a look at these. If you guys want to try these on your own first, then turn the camera back on, go for it. All right, in order to lift the parentheses, they're all being multiplied together first. I don't really put these next to each other like this. I do a lot of this in my head, and so will you. But I'd like to show you how I'm putting them all next to each other for their answer. I could just do this straight and go here, and I expect you to do it too. But I'm just showing you where it comes from. Negative 3 times 4, negative 12, x to the second times x to the first, x to the third, y to the third, y to the second is y to the fifth. That's your final answer. And all you did was use this exponential law that added the exponents together. This one uses the distributing of the exponent to a product of a times b. Remember, you can't do it to a sum. So I'm going to say it's x cubed times t to the fourth cubed, therefore giving you s cubed t to the 12th. And again, most of you are going to skip from this step to this step. You don't need the middle step. So this one, you might need, this one you don't need the middle step. But what you've got here is a negative x cubed, which I like to think of as a negative 1, and then an x cubed, and then they're going to be squared. So a negative 1 squared becomes a 1, x cubed to the second power becomes x to the sixth. Now, if you did it the long way, you're not going to use exponential rules. But you that means I have negative x cubed and I'm multiplying it by negative x cubed and I'm getting x to the sixth. It's really not the best way to do it because now you're going to have to do it the long way for a lot of things. Exponent rules are shortcuts that someone's invented for you. So why would you want to do the long way? That's the question. All right, so the next one is u to the first times u to the sixth, not the second, u to the sixth, and then u to the fifth. You add those all together, 1 plus 6 plus 5, and you get u to the 12th. Again, you hopefully turned off your camera so that you could, see how to do this. This should have been written simplify, which it was. I should have written this one as the word simplify. I didn't do that on the next page either. So this one becomes 3 cubed, x cubed, y squared cubed, z cubed. Again, if you have your camera, had it turned off and did it on your own, that was probably better so you can test yourself. So you get 27 x cubed, y to the sixth, z to the ninth, final answer. Some more simplifying on the next page and then a solve. And then I assign your next homework. So example set 3 is still simplifying. I just didn't write that for you. And you're going to distribute the 3t squared to 4 terms. 3t squared to another term. and then the 3t squared to another term, and then the 3t squared to another term. A lot of you can do this one in your head, but again, as a teacher, I have an obligation to show you where I got the work, but some of you can do it in your head. So next, this would be 3t to the 5th minus 6t to the, did I miss a t squared here? T to the 4th plus 3t cubed minus 12t squared. And none of them are like terms. They weren't in the first place. Circle your answer. I am still simplifying here. And then on this one, I'm going to be solving. Okay, on the simplify, you get a to the 2k times a to the 3k, to which you then add those exponents, and you get a to the 5k. Now, this one does get people confused a little bit, so this is why I write it out. Remember, if you had something that said x to the 2nd times x to the 3rd plus x to the 4th, try to remember that you would say x to the 2 plus 3, but you'd do it in your head, right? But you'd add the plus sign like that. Then you'd say plus x to the 2 plus 4. And then you'd get x to the 5th, x to the 6th. The same thing is happening here. You're doing x to the m minus n plus m plus n. Then you're saying plus, see there's your plus right here. You now are going to distribute x to the m minus n again, and then you're going to add the n. So let me show you what you did. I'll show it to you in color coding. You distributed this m minus n like you distributed this 2 when you added 2 plus 3 and 2 plus 4. You distributed the m minus n, so that it could add with, let's say, this 3 and this 4. So it could add with this guy right here and this guy right here. That's all you did. Some people, again, could do that in their head, no problem. So this becomes x to the, again, do you really need to write this all out? If you do, go for it. Some people can do this in their head and realize these ends cancel, so you get x to the m. These ends cancel, so you get x to the 2m. These do not add together because they're not like terms, so that's your final answer. So if you wanted to solve this one, this one is like setting it up like this guy over here on page 6, where you said, I'm going to take the coefficient, that's awkward coefficient of a minus 2, and let it equal 0. The awkward coefficient of negative 3 plus c, and let it equal 1. The awkward coefficient 2b plus 5, let it equal 1. The awkward coefficient of negative 2 plus 4d, and let it equal negative 6. Little thing going on over here where you're going to let the exponents equal each other. So if I said to you, b to the 8th is equal to b to the n, wouldn't just 8 equal n? So you solved and you say n is equal to 8. So if I could get this down to, I'm going to say this, 3 to the something, and it could equal to 3 to the other something, because you see how this is the same base and that is the same base, then I could let these two equal each other, and then I can solve. So I'll show you how that's done in a second. So this is 3 to the 1st, but that 9 is not a 3, so you got to make it a 3. So the 9 is really a 3 squared, right? You got to make everybody the same base, because you got to, if you had this base equaling this base, b for base, then the exponents equal each other. So if this base equaled this base, the exponents equal each other. So this base is 3 to the 1st power, this base is 2 to the 2n power, so which is, by the way, 3 to the 1 times 3 to the 4n, okay? So that means I'm going to keep the base and add the exponents. So that means on this side, I get 3 to the 1 plus 4n. On this side, I just distribute, right, because I'm multiplying n plus 1 times the 3, right, because when you have this rule over here, a to the m to the n, you just multiply m times n, 2 times 3. In this case, you just have a binomial to multiply, so it has to be 3 to the 3n plus 3. I'm just going to have to write that a couple times. It's not that bad. 3n plus 3, so 3n plus 3. Now that the bases are equal, I know that 3 equals to 3. I can just set the exponents equal to each other and solve for n. In my last problem, so I solved this by subtracting the 3n from both sides, the 1 from both sides, so 1n equals 2, and n equals 2. So that is an example of solving with exponents. So the other homework you have is found on section 4.2. It's page 173, 2 through 38 even. You can't check those because they're even, so I will give those answers to you. I may post them for you, or I may give them to you in class on Friday, but either way you will get them. So don't forget to write your originals. So you do have 2 sections you're going to post, 4.1 and 4.2. I will let you know in Google Classroom how to post them and when to post them.